Aldehyde. Aldehyde is an organic compound and considered as one of the most important functional groups. It integrates a carbonyl group that bonded to its at least one hydrogen atom. Aldehyde contains a structure that shares a double bond to oxygen, a single bond to hydrogen atom, and a single bond to another atom. So how do we name an aldehyde? In naming aldehyde, it has similar on naming of alcohol. But in aldehyde, the end of the parent name is changed to the suffix -al. Also, the double bond of the oxygen is positioned already at the carbon 1, which means that we don't need to determine the numbering position of the oxygen because it is already a number 1 position. In naming aldehyde, we need to find first the longest carbon chain in the structure by numbering it. In our example, we have here a 6-carbon aldehyde. So then, the prefix of our structure will be hexa. And here will enter the suffix of the aldehyde, which is the suffix -al. Now, the name of our structure will be hexanal. Now, in making the structure of an aldehyde, we have here an example which is the butanol. So first, we need to identify the longest chain based on its prefix. Our prefix here is buta, which means our longest carbon chain contains the number of 4. After that, we put our aldehyde on the position of carbon 1, so that we have the structure of our example, which is the butanol. And that is the end of our topic, aldehyde. Phenol. Phenol is also called as carbolic acid, is a class of organic compound consisting of one hydroxyl group or OH group that bonded directly to an aromatic hydrocarbon group. Phenol is consists of molecular formula C6H5OH. So how to name a phenol? In naming phenol, we give the number of the position 1 to the phenol, and the name phenol is added right at the end of the substituent's name. Here we have our example. First, we count the number of the ring to acquire the position number of our substituent. Note that the OH is our phenol. So our metal is positioned in the number of 4, so we have a name of 4-methyl phenol.
For this example, 3-methyl-2-pentanol. The ending OL indicates an OH functional group. The pent stem tells us that there are 5 carbon atoms in the longest carbon chain. We start by drawing a chain of 5 carbon atoms. The number indicates that there is a methyl group on the 3rd carbon atom and an OH group on the 2nd carbon atom. Now, this is our structure of 3-methyl-2-pentanol. Let's talk about nitriles. Nitriles are analogous to carboxylic acid in that both have carbon atoms with 3 bonds to an electronegative atom. Nitriles are also called cyano compound, any of a class of organic compound that have molecular structures in which a cyano compound is attached to a carbon atom. Nitriles are also colorless, solids, and liquids with distinctive odors. In this example, we identify that the highlighted part is our parent chain. It has 6 carbons with the name of hexene. Hexene plus nitrile with the final name of hexene nitrile. In this second example, the highlighted part is our parent chain. It has the longest carbon chain. It containing 5 carbons with the name of pentene. Pentene plus nitrile is pentene nitrile. We have the substituents in carbon 2, which is the ethyl group, and the carbon 3, which is the hydroxyl group, alphabetized with the final name of 2-ethyl-3-hydroxypentenetrile. To draw the structure of this example, cyclohexane carbonitrile. First, we draw a cyclohexane and attach the nitrile in carbon 1.
Ketone. Ketone is a functional group that integrates a carbonyl group with the structure of R2C double bond O. So how do we name ketone? In the IUPAC system, Ketone are classified by the suffix "on." So in naming ketone, we replace the "e" ending of the parent name to the suffix "on." And then we number the structure to acquire the lower number that be given to carbonyl carbon. In naming the structure, we need to identify first the longest carbon chain to acquire the prefix of the structure. Here in the example, our longest carbon chain contains the prefix of pentane. So, we need to change the ending of the parent name to the suffix 1 to form the name pentanol. And then, we number the carbon chain to give the lower number to the carbonyl carbon, which here in our example is on the position of number 2. In making the structure of ketone, we have here an example to elaborate the process of making the structure. So, we have here an example of 2-butanol. First, we need to identify the longest carbon chain based on its prefix. Our prefix here is buta, which means our longest carbon chain is 4. After that, we count the carbon chain to identify the position of our carbonyl carbon. So here in our example, the carbonyl carbon is positioned in the number 2. So that's how our structure acquired the name of 2-butanol.
Naming carboxylic acid. Carboxylic acids are identified by a suffix added to the parent name of the longest chain. If the COOH is bonded to a chain of carbons. Step 1. Find and name the longest chain containing COOH and change the E ending of the parent alkene to the suffix uic acid. For example, hexane plus uic acid equals hexanoic acid. Step 2. Number the carbon chain from 1 to 6 and name the substituent. The substituents of C4 and C5 are both methyl, and the answer are 4, 5, dimethyl hexanoic acid. But what if the COOH group are bonded with a ring? Step 1. Name the ring and add the word carboxylic acid. For example, cyclohexane plus carboxylic acid, which read as cyclohexane carboxylic acid. Step 2. Number the carbon chain or ring to put COOH group at 1 and give the second substituent the lower number, which is number 2. Finally, combine the steps that result as 2, 5, 5, trimethyl cyclohexane carboxylic acid.